As we chat, the night sky is going through radical changes that will modify its appearance in many years or even sooner. Experts and astronomers worldwide have sounded the alarm, with figures like Neil deGrasse Tyson warning that Polaris is about to undergo a massive transformation. The event behind this change is deeply concerning. Polaris' unique position in the night sky has made it a crucial marker as the North Star, serving as a constant reference for astronomers, pilots, and stargazers throughout history. Yet, this reliability may soon be disrupted, potentially reshaping both the night sky and the astronomical measurements we rely on. We should dive into the gravity of this threat and explore its implications for all of us. To understand this, it's crucial to look at the historical significance of Polaris, which is now in its final stages. Polaris has long been revered as the guiding star, a beacon for astronomers and pilots over the ages. Its consistent presence in the sky has been key to celestial navigation. However, all of this could suddenly change. A new report, published by the esteemed Royal Astronomical Society in September 2023, casts doubt on the star's future. Polaris is on the verge of an explosion that could remove it from the night sky forever. Before we explore the implications of this discovery, let's take a closer look at the star itself. Polaris, also known as the North Star, holds a distinctive position in the sky due to its proximity to the celestial North Pole. It is located directly above Earth's North Pole, making it appear unmoving in the northern sky. The star resides within the constellation Ursa Minor. Polaris is a moderately bright, yellow-white supergiant, significantly larger than our Sun. While it may seem like a single star, it is actually part of a complex triple-star system. Within this system, the primary stars are Polaris AA and Polaris AB, which, when viewed with the naked eye, appear as a single star. Additionally, there is a third companion, Polaris B, orbiting around the binary pair. The gravitational forces between these stars shape their orbits and influence their individual behaviors, which in turn affect their brightness and other key characteristics. Any disturbance in these interactions can lead to irregular changes in the star's luminosity or pulsation patterns, although the exact details of these phenomena are not fully understood. Polaris is located approximately 323 light-years from Earth. This means that the light we see from it today was emitted 323 years ago. This vast distance implies that if Polaris were to explode today, we wouldn't be aware of it until 323 years later. Therefore, if we were to witness such an event, it would have actually occurred over 3 centuries ago. Current scientific projections, based on available evidence, suggest that Polaris may have already exploded, but the light from that explosion has yet to reach us. Throughout history, the North Star has held great significance across civilizations and eras. It has served cultural, symbolic, and navigational purposes. Its fixed position near the celestial North Pole has made it an essential tool for ancient sailors and travelers, guiding them across seas and lands. Nearly aligned with Earth's rotational axis, it has been a reliable reference for determining direction, particularly in the northern hemisphere. The North Star holds profound symbolic importance in various cultures. For many, it represents stability and security, a constant in the ever-changing celestial dance of the night sky. However, in recent years, this star has exhibited unusual behavior. This alarming shift in its pulsation cycle has caught the attention of astronomers, prompting further investigations into this cosmic anomaly. Instead of following its usual pulsation pattern, Polaris has displayed an unpredictable and erratic cycle of dimming and brightening. This variation has sparked concerns among scientists, who fear the star may be nearing the end of its life. This shift aligns with the behavior observed in stars approaching the final stages of their life cycles. The increasing irregularity in Polaris pulsation periods, which were once stable, may be due to interactions between the star and its companion system. Although these stars appear as one, they are affected by each other's gravitational forces. There has been a noticeable increase in pulsation length, around 4.5 seconds longer. While this might seem insignificant, it carries major implications. Some astronomers cautiously speculate that gravitational forces between the stars could explain these fluctuations in the star's atmospheric behavior, thus affecting its pulsation patterns. However, other scientists firmly believe that the star is nearing a catastrophic end. Their suspicion is fueled by the growing similarities between Polaris behavior and that of Betelgeuse, another prominent star in the Orion constellation that has exhibited abnormalities in its brightness, leading to concerns that it could explode at any moment. Some experts have warned that Betelgeuse's end is imminent, citing its unpredictable brightness and behavioral traits typical of stars in their final stages. NASA, intrigued by Betelgeuse's anomalies, has shown significant interest in monitoring the star. The agency has expressed considerable concern about its potential explosion. However, NASA has not indicated the same level of concern about Polaris, despite its unsettling behavior. Stars typically undergo an extensive evolutionary journey through various stages. In their early years, they are relatively dim and cool. As they mature, they enter the main sequence stage, where nuclear fusion occurs, maintaining stability for billions of years. When their hydrogen fuel is depleted, they enter the red giant stage, during which they rapidly increase in both temperature and brightness. This stage culminates in a cataclysmic explosion known as a supernova. If Polaris were to go supernova, it would be a spectacular event in the sky. The star would become incredibly bright, potentially outshining the moon and becoming one of the most luminous objects visible in the night sky. This radiant display could last for days, weeks, or even months. The star's appearance would change dramatically, transforming into an intensely bright object, possibly exhibiting various colors before eventually fading away. This visual phenomenon could temporarily alter our perception of familiar constellations like Ursa Major and Ursa Minor, as Polaris is part of both. Regarding the safety of our planet, there is no immediate danger. Given Polaris' size and distance, it is highly unlikely that Earth would be affected by a stellar explosion. While a Polaris supernova may not be as dramatic as Betelgeuse's potential eruption, it could still be visible to the naked eye for an extended period and outshine nearby stars. The potential supernova of Polaris, though distant, would be a cosmic event that could transform our understanding of stellar evolution. Such a spectacle could bring both awe and confusion, especially to those who have long relied on the North Star as a steady guide. Its absence from the night sky would be a disturbing change for many, particularly those accustomed to its role as the focal point of celestial navigation. While Polaris is certainly in its final stages, it is important to remember that the journey of stars like this is part of the natural life cycle. Over billions of years, stars undergo constant change. As they age, they become unstable, and their behavior grows increasingly erratic. Polaris, a massive supergiant, is no exception, with the possibility of its explosive end looming in the future. Astronomers and scientists are now carefully monitoring the star's movements and behavior, hoping to gather as much data as possible before any drastic changes occur. Though Polaris has been a constant presence in the sky for countless generations, its inevitable fate is a reminder of the dynamic nature of the universe. The stars we see in the sky are not permanent fixtures. They are constantly evolving, and their lifespans can end in dramatic ways. The potential disappearance of Polaris, whether through a supernova or another cosmic phenomenon, will mark the end of an era for astronomers and stargazers who have relied on it for centuries. For now, scientists continue to study Polaris and other similar stars to better understand the processes that drive their changes. Whether Polaris explodes soon or not, the data gathered from these studies will provide crucial insights into the life cycles of stars and the forces that shape the universe. Meanwhile, we can watch as the night sky slowly changes before our eyes, a reflection of the ever-changing universe around us. As we observe these celestial developments, it is clear that our understanding of the night sky is in a state of flux. The once constant stars that guided ancient civilizations are no longer as steady as they once seemed. This shift in our celestial landscape challenges our perceptions and reminds us of the vast, unpredictable nature of the universe. Though the explosion of Polaris may not directly impact life on Earth, its absence from the sky would be felt by many. The North Star has long symbolized stability and guidance, and its loss would serve as a stark reminder of the impermanence of the cosmos. As the world's astronomers kept their eyes fixed on Polaris, a growing sense of anticipation filled the scientific community. Observatories worldwide had begun intensifying their efforts, using advanced telescopes and spectrometers to analyze every fluctuation in the star's light. Then, one night, an unprecedented event occurred. Across the northern hemisphere, astronomers, both professional and amateur, noticed something extraordinary. Polaris flickered, its brightness waning and surging erratically. It was an unmistakable sign that something monumental was unfolding. Within hours, observatories reported that Polaris' luminosity had increased tenfold. The once steady beacon of the night sky now shone with a brilliance never seen before. News of Polaris' sudden change spread like wildfire. Scientists scrambled to interpret the data. Had the long-predicted supernova begun? Was Polaris truly at the brink of its explosive end? If so, the world was about to witness one of the most spectacular astronomical events in recorded history. Days passed, and Polaris continued its erratic behavior. Then, on a quiet evening, the unthinkable happened. A blinding flash erupted from the North Star's position, a burst of light so intense that for a moment, night turned to day. Across the globe, millions of people stepped outside, staring in awe and disbelief. Polaris had finally detonated. For weeks, the sky remained changed. Where Polaris once stood, an enormous radiant cloud of gas and dust expanded outward, a supernova remnant glowing brilliantly against the darkness. The night sky, once so familiar, now bore a celestial scar, a reminder of the ever-changing nature of the cosmos. But the consequences went beyond just a breathtaking sight. Without Polaris as a fixed reference, traditional celestial navigation was thrown into turmoil. Pilots, sailors, and astronomers had to rely on alternative methods. The absence of the North Star forced humanity to rethink its connection with the night sky. Meanwhile, scientists rushed to study the explosion, hoping to unlock secrets of stellar evolution. Powerful space telescopes captured data, analyzing the event in real time. For the first time in human history, an iconic guidepost of the sky had disappeared before their eyes. Yet, as the dust settled, both figuratively and literally, a new realization dawned. Though Polaris was gone, its legacy remained. The universe had once again reminded humankind of its impermanence, yet also of its endless mysteries waiting to be explored. The aftermath of Polaris supernova. As weeks turned into months, the remnants of Polaris explosion continued to expand, forming a dazzling nebula visible even to the naked eye. Scientists named it the Polaris Remnant, a glowing testament to a star that had guided humanity for millennia. The world was still adjusting to the absence of the North Star. For centuries, travelers had looked up to find their way, but now, for the first time in recorded history, there was no single, fixed point in the northern sky. Astronomers worked tirelessly to establish new celestial navigation methods, while spacecraft and satellites recalibrated their instruments to account for the missing reference. Yet, amidst the scientific chaos, something unexpected happened. A new light in the north. One evening, observatories across the world detected an anomaly, a faint, unfamiliar glow emerging from the heart of the Polaris remnant. At first, scientists thought it was just the supernova's lingering light, but within days, the glow intensified. Something was there. Excitement spread through the astronomical community. Telescopes focused on the nebula, revealing something that defied expectations. A newborn star was forming within the debris of the explosion. The remnants of Polaris had given birth to something new. The birth of Polaris Nova. Scientists named the emerging star Polaris Nova, a second-generation celestial body forming from the very materials left behind by its predecessor. It was a phenomenon rarely witnessed, an opportunity to study stellar birth in real time. Telescopes worldwide tracked its growth, observing as its brightness fluctuated. Some predicted it would stabilize and become a new guiding star for the northern hemisphere. Others speculated it could remain an unstable variable star, flickering unpredictably. Despite the uncertainty, one thing was clear: the night sky was not done changing. Humanity's renewed curiosity. The birth of Polaris Nova ignited a new wave of fascination with the cosmos. Space agencies prioritized missions to study the phenomenon up close, and the global space community proposed an ambitious project, the Polaris Nova probe, a spacecraft designed to travel to the nebula and collect data directly from the forming star. The mission promised answers to questions that had puzzled astronomers for centuries. How did stars truly evolve? Could humanity witness the full life cycle of a celestial body within a single generation? As construction of the probe began, the world turned its eyes once again to the sky. Polaris Nova was not yet the beacon its predecessor had been, but it carried the promise of something new, an evolving mystery waiting to be unraveled.